So the symbolic representation, that is the Venn diagram to represent the union of two sets, is 1, 2, 3, 4, 5, 6. Everything comes under this set, that is called the union of sets. The elements which are common to both A and B is nothing but the intersection of two sets, denoted as A intersection B is equal to X, such that X belongs to A and X belongs to B. The intersection of a union of a set and a set is always equal to the same sets itself. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the definition and the problems based on the construction of sets. Now in this session, I am going to discuss regarding the operations on sets like union, intersection, difference, and the complementation of set. Now let us start with the union of sets. Now union of sets. Union means it is nothing but the combination of all. Combining all together is called the union. Union means nothing but, in general, union means combining all, uniting all. So here also in set, combining all the elements of the sets, number of sets. If there are two sets, combining all the elements of the two sets, or three sets, combining all the elements of the three sets. So how to define mathematically? Let A and B be any two sets. Let A and B are any two sets. Then the union of A and B is the set which contains all the elements of A and all the elements of B. The union of two sets A and B is all the elements of the set A and all the elements of the set B, the common element being taken only once. The common element being taken only once. So, and the symbol for representation of the union of set is U. The symbol U is used to denote the union of two sets. Symbolically, we can write A union B. Read it as A union B. Now, that is, let A and B any two sets. The union of two sets A and B is a set which contains all the elements of A and all the elements of B, and the common elements being taken only once, and it is denoted by the symbol A union B. So this is the symbolic representation of A union B, and read it as A union B. Now let us take an example. Here, let us take, let A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. To find A union B is equal to all the elements of A and B. That is, A contains 2, 4, 6, 8 and B contains 6, already we have written, 8 already written, 10 and 12. So therefore here, A union B is equal to all the elements of 8. Write first A, 2, 4, 6, 8. Then the elements of B, 6 is there already, 8 is also included. Then write down 10 and 12. So this is how we are going to write the union of these two sets. Now let us come to the exact definition, mathematical definition for union. So definition of union of sets. The union of two sets A and B is the set C. The set C. The union of A and B, the union of two sets A and B is the set C, which contain all those elements which are either in A or in B, which contains all the elements which are either in A or in B, including those elements which are in both. So this is denoted as A union B and is defined by A union B is equal to a set X such that X belongs to A or X belongs to B. That means all the elements which belongs to A or which belongs to B, that is A union B is equal to a set X such that X belongs to A or X belongs to B is nothing but the union of two sets. Now, the union of two sets can be represented in a diagram that is called the Venn diagram. In a Venn diagram, we are going to represent union of two sets like this. This is the universal set. This is set A and set B. The union of set is nothing but all the elements of the set which are in A or in B. So this is the union of sets. So the Venn diagram to represent the union of sets. Now let us take for example, if A is equal to 1, 2, 3, another set B is equal to 3, 4, 5, 6, then the union of this is denoted as A union B is equal to, write down all the elements of the set A, 1, 2, 3, and the elements of the set B, repeated being avoided. Just you can write only once, the repeated element can be written only once. 3 is already there. We can write 4, 5, and 6. So, here, this is nothing but the element which is common to these two sets are 3. So, here 3 comes here, and the remaining elements, all the elements of A are 1, 2, and 3. All the elements of B are 3, 4, 5, 6. So, the symbolic representation, that is the Venn diagram to represent the union of two sets is 1, 2, 3, 4, 5, 6. Everything comes under this set, that is called the union of sets, the Venn diagram. So, here if A and B are any two sets, then the union of two sets A and B is denoted as A union B is equal to a set X such that X belongs to A or X belongs to B. Now, let us come to the properties on union of sets. Now, there are few properties based on this union of sets. What are the properties? A union B is always equal to B union A. That is, A union B is equal to B union A means it is nothing but a commutative law. So, commutative law is satisfied. So, union of two sets are commutative. A union B is also equal to B union A. Therefore, it is commutative. Commutative. Now, A union B union C is also equal to A union B union C. Just A union B union C is also equal to A union B union C. That means it is associative. Associative property is satisfied. Associative property holds good. So, union of two sets is commutative. Union of two sets is associative. Now, A union null set is equal to A. Law of identity element. That is identity element. This null set is an identity element of U. So, A union null set, the union A and the union of a null set is always equal to the same set A. If you take the union for a null set and the set, you will get all the elements of the set A itself, you will get the same set. Now, similarly, A union A, if you take union for the same set A and A, you are going to get the same set. A union A is equal to A. And universal set and a set is always equal to universal set, where U is the universal set. This is the universal set. So, union of universal set and a set A is also equal to the universal set itself. So, these are the few properties on union of sets. Okay. Now, let us come to the next concept, that is intersection of two sets. We have intersection of two sets. Now, let us come to the next concept, that is intersection of two sets. Now, intersection means the intersection of two sets A and B is the set of all elements which are common to both A and B. The elements which are common to both A and B. The common elements, same elements. The intersection of two sets A and B is the set of all the elements which are common to both A and B, and it is symbolically denoted as, the symbol for intersection is reverse U and is used to denote the intersection. The intersection of two sets A and B is the set of all those elements which belongs to both A and B, and it is symbolically denoted as A intersection B, and is given by A intersection B is equal to a set X such that X belongs to A and X belongs to B. Say, whereas in union, A union B is equal to a set X such that X belongs to A or X belongs to B. Whereas in intersection, A intersection B is a set X such that X belongs to A and X belongs to B. This is the intersection. The elements which are common to both A and B is nothing but the intersection of two sets, denoted as A intersection B is equal to X such that X belongs to A and X belongs to B. Now, let us consider an example. Let A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. The intersection of these two sets are nothing but the common elements. So, here we can see 6 is in the set A, 6 is also included in the set B. So therefore we can write A intersection B is equal to first element is 6, and 8 is included in the set A and 8 is also included in the set B. Therefore we can write 6 comma 8 is the intersection of A and B. So 2 is in the set A whereas 2 is not in the set B. Similarly 4 is in the set A, 4 is not in the set B. Similarly 10 and 12 are in the set B but they are not in the set A. Therefore we can say that the common elements are 6 and 8. Therefore the intersection of A and B is given by A intersection B is equal to 6 and 8. So only 6 and 8 are only the common elements which are in A and B. Therefore the intersection of A and B is A intersection B is equal to 6 comma 8. Okay. Now let us come to few properties. Same before properties in general, the definition, the mathematical definition, the intersection of two sets A and B is the set of all those elements. Set of all those elements which belongs to both A and B, and it is denoted as A intersection B is equal to X, such that X belongs to A and X belongs to B. That is, the intersection of two sets A and B is the set of all those elements which belongs to both A and B, and it is given by, denoted by A intersection B is equal to X, such that X belongs to A and X belongs to B. Both elements belongs to A and B. Now, the standard portion of the figure indicates that is the shaded. Actually, the shaded portion, the standard portion is nothing but the shaded portion indicates the intersection of the two sets A and B. This is the Venn diagram. So, the Venn diagram for representing the intersection of two sets, this is the common region, the standard region, the shaded region will give the intersection of the two sets. Now let us consider, for example, same element 2, 4, 6, 8 and set B contains 6, 8, 10 and 12. The intersection of these two sets is denoted as A intersection B is equal to only the two elements 6 and 8. So here what is A contains 2, 4 and what is B contains 10, 12. The intersection of these two is given by, so A contains 2, 4, 6, 8, 6 and 8. B contains 6, 8, 10, 12. So A intersection B is nothing but the elements 6 and 8 in the set is nothing but the A intersection B. So the elements A intersection B is represented by the shaded region or the standard region. Now, this is how we are going to represent the elements of intersection in a Venn diagram. Okay. Now, let us discuss the properties on intersection of sets. The properties of intersection of sets. Now, A intersection B is also equal to B intersection A. That means intersection is commutative. Again, it is associative. A intersection B intersection C is also equal to A intersection B intersection C. So, union as well as intersection of two sets is both associative as well as commutative. Now, intersection of a set and a null set. Null set intersection A or is always equal to the null set, because the intersection of a null set and a set is always equal to a null set, because common elements. Now, no elements present in the null set, therefore the intersection of a set and a null set is always a null set. Similarly, the intersection of a union of a set and a set is always equal to the same sets itself. Intersection of universal set and a set A is equal to the same set. Then the intersection of two same sets is equal to the same sets itself. A intersection A is always equal to the same set. Now let us discuss the distributive law. So A intersection B union C. A intersection B union C is always equal to A intersection B union A intersection C. See, A intersection B union C is equal to A intersection B union A intersection C. This is the distribution law. So, distributes over the union. So, these are a few properties on intersection of sets. Now, let us come to the difference of two sets. Next concept is the difference of two sets. So what is the meaning of difference of two sets? The difference of two sets A and B is this order is a set of elements which belongs to A but not to B. All the elements which belongs to A does not belongs to B is called the A difference B. That is denoted as A minus B. Symbolically we can write A minus B and read it as A minus B. So A minus B means A minus the elements which are in A but not in B. That is called A minus B. So this is called the difference of two sets. Now let us take an example. If A is equal to 1, 2, 3, 4, 5, 6, B is equal to 2, 4, 6, 8, then the difference of A minus B and B minus A. Now, we have A minus B, elements which are in A but not in B. So, in A we have 1, it is not there, 2 is there, 3, we have 3 in A but 3 is not in the set B. So, we can take 3 also, 4 is there, 5 is in A but not in B. Therefore, the elements of A minus B are 1, 3 and 5. A contains 1, 3 and 5. Similarly, if we come to B minus A, elements which are in B but not in A is nothing but B minus A. So, 2 is there, 4 is also there, 6 is also there, 8. So, only it contains one element 8. So, therefore, A minus B is nothing but 1, 3, 5. Whereas B minus A, elements which are in B but not in A is, so see here A minus B is not equal to B minus A, right? So the Venn diagram to represent A minus B and B minus, the difference of two sets is A minus B. This is A minus, the elements which are in A but not in B. So elements, this shaded region, the standard region, the shaded region will give the elements which are in A but not in B. That is called A minus B. B minus A, A minus B. So here this is the intersection. If this is included in this intersection, A minus B and A intersection B, this is nothing but B minus A. Elements which are in B but not in A is denoted here, B minus A. So this is how we are going to represent A minus B and B minus A and A intersection B in the Venn diagram. Now let us come to a few examples based on this union, intersection and difference of sets. Now the first exercise 1.4. Find the union of sets A and B for the following pair of sets. Now first problem. What is the first problem? If x is equal to 1, 3, 5 and y is equal to 1, 2, 3, what is required to find is the union. So x union y is equal to all the elements of the set which are in A or in B. So here A contains 1, 3 and 5. B contains already, x contains 1, 3, 5 and y contains 1 already. 1 we have written, 2 is not there, 3 is also written. So therefore we can write x union y is equal to a set in order 1, 2, 3 and 5. This is the union of the given set. So x union y is equal to 1, 2, 3, 5. Okay. Now let us come to the next problem. Same, find the union of each of the following pair of sets. Second question. What is the second answer? A union B. A union B can be written as the elements which are in A and B, that is A, E, I, O, U, and here we have A already written. You can take B and you can take C. So therefore we can write in order A union B is equal to A, B, C, E, then I, O, U. These are the elements. So that is A, E, I, O, U and B, C. A, B, C, E, I, O, U. These are the elements of the set A union B. Now, next. This is given in the form of a statement. So, x, A is equal to x such that x is a natural number and multiple of 3. Multiples of 3. A natural number which is a multiple of 3. And B, x such that x is a natural number less than 6. Now for this we have to write the union. Before writing the union, just write down the elements of the set A and B. We have to write the union for the pair of this. What is x? X is a natural number and multiple of 3. So this is an infinite set. A is equal to, x is a natural number and multiples of 3. The multiples of 3 are 3, 6, 9, 12, etc. These are all the multiples of 3. 3 ones are, 3 twos are, 3 threes are, 3 fours are, 3 fives are, like that. 3, 6, 9, 12, etc. Now what is B contains? B is equal to, X is a natural number less than 6. Natural number less than 6 is nothing but 1, 2, 3, 4 and 5. So what is to write the union of this? Therefore, the union of these two is A union B is equal to, write down B first, 1, 2, 3, 4, 5 and then already 3 is there, 6, 9, 12, etc. So this is an infinite set you are going to get. So A, what is A? A is a natural number, X is a natural number and multiple of 3. 3, 6, 9, 12, they have not given. Just the multiple of 3, that's they have given. It is an infinite set, 3, 6, 9, 12, etc. And B, X is a natural number less than 6. Here they have mentioned it is less than 6, means 1, 2, 3, 4, 5. The A union of these two is 1, 2, 3, 4, 5, 6, 9, 12, etc. This is the union of this given set. Now, let us come to the next set. Find the union. So, what is given? X is a natural number and X is in between 1 and 6. X lies between 1 and 6 and XB. X is a natural number, 6 less than X less than 10. So, write down the elements of the set A. A is equal to, what is given A? A natural number, X lies between 1 and 6. So, the values of 1 and 6, 1, 2, 3, 4, 5 and 6. The values of X in between 1 and 6, that is nothing but 2, 3, 4, 5. X is less than or equal to 6, means including 6 also. So, 2, 3, 4, 5 and 6. Whereas B, what is B? X is a natural number which lies between 6 and 10. So, 6, 7, 8, 9 and 10. In between 6 and 10 are 7, 8 and 9. 7, 8 and 9. Now, therefore, the union of this is given by A union B is equal to, write down the elements 2, 3, 4, 5, 6, then 7, 8 and 9. These are the union of these sets. Okay, this is very important and very simple problem. What is defined? A is a natural number. A, X is a natural number and which lies between 1 and 6. 1 less than X less than or equal to 6 means, write down the values from 1 to 6. You see the condition. What is the condition? 1, X lies between 1 and 6. Less than or equal to 6. Equal to 6 means 2, 3, 4, 5 and 6. Whereas another set B is nothing but a natural number which lies between 6 and 10, means all the values from 6 to 10. Write down the elements from 6 to 10. 6, 7, 8, 9 and 10. See the values which lies between 6 and 10. 7, 8 and 9. So, 7, 8 and 9. Therefore, the union of these two sets is 2, 3, 4, 5, 6, 7, 8 and 9. That's it. Okay. Now, let us come to the next problem. What is given? Find the union of each of the following pair of set. What is given? A is equal to 1, 2, 3 and B is a null set. So, here A is equal to, elements of the set are 1, 2 and 3, whereas B is a null set. The union of a set and a null set. So, what is A contains? A contains 1, 2, 3 and B contains a null set. So, the union according to the property, we know this, A union null set. A union null set is always equal to the same set itself. So, therefore, this is equal to 1, 2 and 3, the same set. That's all. So, A union null set is equal to a same set. Since A contains 1, 2, 3, B contains null set, the union of these two is nothing but the same sets itself. A, 1, 2 and 3, the same set. Okay. Now, let us come to the next set of problems. If A is equal to AB, B is equal to ABC, is A is a subset of B, and what is A union B? Now, first condition, verify whether A is the subset of B. A contains A comma B and B contains A, B, C. So, A is the subset. Therefore, A is the subset of B because all the elements of A are the elements of the set B, therefore E is the subset. A is the subset. So yes, this condition is satisfied. Yes, A is the subset of B. Because all the elements of A are the elements of the set B, therefore A is the subset of B. Now, what is the union? The second part, the union, A union B. Write down the elements of A, B and C. That's all. So, A union B is equal to the set B itself. So, since A and B is in the set A, B, C are in the set B. So, A is a subset of B and the union of this set is nothing but the elements which are in A and B are nothing but A, B and C. Okay, right. Now, let's come to the next problem. If A and B are any two sets such that A is the subset of B, then what is A union B? See here, what is given? Given that for any two sets A and B, A is the subset of B. Now, A is the subset of B means, according to the definition, all the elements of A must be the elements of set B, right? So, then only A is the subset of B. So, all the elements of A must be the elements of the set B. So, if A is the subset of B means, then A union B, A and union is always equal to the same set B. A union B is equal to B, right? So, see here, if A and B are any two sets such that A is a subset of B, then what is A union B? Here, since given, what is given for any two sets, A is the subset of B. According to the definition of subset, all the elements of A must be the elements of set B. So, if A is a subset of B means definitely the union of two sets A union B is equal to the set B itself. So, therefore, A union B is equal to the set B. Hope you followed this. So, here that is given that A is the subset of B and then what is to find A union B? Since all the elements of A must be the elements of set B, therefore, A union B is nothing but the set B itself. So, that's regarding the union, intersection and the difference. So, the very important concept here is, what we have studied here is the union. For any two sets, A union B is equal to X such that X belongs to A or X belongs to B. And the intersection of two sets is A intersection B is equal to X such that X belongs to A and X belongs to B, the common elements. Now, A union B, A intersection B, A minus B, the difference, the difference of this is A minus B is equal to X such that X belongs to A and X does not belongs to B. So, these are the things which we have studied. B minus A is nothing but X belongs to B and X does not belong to A is nothing but B minus A. The difference of A and B and A minus B and B minus A. These are the few things which we have studied in this session. That's all for today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.